Hi guys, I was asked to do number 9, so this is a follow-up video to the problems on page 165, number 9. And the problem is that you have water flowing into a tank at a rate shown by this graph here. Okay, so at time equals 0, there's no water in the tank. At time equals 1 minute, there is 1 gallon in the tank, and so forth. Okay. And so it says in part A, given a lower and give a lower and upper estimate of the total number of gallons that have entered the tank during the 10 minutes shown in the graph. So what I know is my delta x, my interval width, is 1. Each one of these little subintervals is 1 unit, so it's 1. Now I can do a left-hand sum right from the graph, right? It's delta x times the function evaluated at 0 plus the function evaluated at 1 plus the function evaluated at 2 plus da 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 da, right? All the way up to the function evaluated, let me just add that in there, plus the function evaluated at 10. Okay? So this would give us a left-hand sum. Likewise, we could do a right-hand sum. So left-hand sum means I'm starting with the leftmost endpoints of each interval and going up till I touch the graph to find the height. So let's do that. The left-hand sum is equal to 1. We know our delta x. F of 0 is 0, plus f of 1 is 1, plus f of 2 is 3, plus f of 4, or wait, f of 0, 1, 2, f of 3. F of 3 is 5, plus f of 4 is 6. So these are all representing the sum of the heights of the function, okay, the output values. This delta x is just the width of the interval, because you would be multiplying, you know, if you wanted to find the area of this one rectangle, it would be 1 times the height, which is 1, so the area of this rectangle would be 1. If you wanted to find the height of this rectangle, it would be 1 times 3, or 3, and then you would add those together. So, and of course the area of this would just be 0, right? 1 times 0 height is 0. So anyway, what you're doing is, this is giving you the width times the height for each subinterval, which results in these little rectangles. So you can do it right from the graph if you want to. You know, this is 1 times 5, or an area of 5. Let's see. This one here is a 6, area of 6, 1 times 6. Okay, this one here would be 1 times 7, I think that's a 7. 5, 6, 7, yeah. This one, I'm going to say it's 7.5, so 7.5. This one goes up to 8, so this is an area of 8. This is about, I think, 8.5. And if I go up and touch the graph, my last rectangle, so that looks like, I'm going to call it 8.75 there. I'm writing it really small. But anyway, essentially what I'm doing to get the estimate or the approximation using left-hand sum is I'm using the left-hand endpoints and the heights at each one of those endpoints of the function to find the area of a rectangle. And once I find the area of each rectangle, then I can just add them all together and get the sum. So I'm just going to put a dot, dot, dot here, and you know, we went up to the 9th one, and that's it. You don't go this because, you know, there's nothing out there. So you stop here with the left-hand sum. And plus what, 8.75, and if I add those all together and multiply by 1, what I get is 54.75 gallons. Okay. Now if I want to do a right-hand sum, the interval width is not going to change ever, so it's going to be the same. The difference is, so in this subinterval here, I'm not going to start at 0 anymore, I'm going to start at 1, so I'm going to go, let me erase this, okay? Let me just erase this. Oops, there we go. So each one of these is a subinterval here, right? From 0 to 1, from 1 to 2, to 2 to 3, and so forth. So with the right-hand sub for this subinterval, I'd start here and go up and over and down. So it's 1 times 1, or 1. So you see, I'm not, here I started with the area of 0. Now I'm starting with the next term. 1 plus, guess what? That one's a height of 3 times 1, it's 3, so 1 plus 3 plus 5 plus 6. So I'm using the same exact numbers, except not the very first number from the left-hand sum. And in this one here, I didn't include the very last number, f of 10. Here I will. So dot, dot, dot. We're going to keep, repeating this process. Okay, over and over and over. And we're going to add up all of these things. And the last one here, f of 10, has a height of 9, it looks like. So plus, 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 all the way to 9. So if I add all these up and multiply by 1, that's going to give us 63.75 gallons. And this makes sense because this is an increasing monotone function. So the left-hand sum is going to be an underestimate, and the right-hand sum, as you can see on some of my rectangles here, is going to become an overestimate. It's going over the graph. Okay, and so they wanted you to give a lower and upper sum. Well, in this case here, a left-hand sum or a lower sum. Lower sum is sometimes denoted, LS, and an upper sum US, like that, or L and U is used. So anyway, however you want to write it, the left-hand sum is going to give us an underestimate, and the right-hand sum is going to give us the overestimate, okay, in the 10 minutes shown on the graph. So in part B, it says if the average of the lower and upper estimate in part A is used to approximate the exact number of gallons, how accurate is the approximation? Well, what we know is we're going to take the lower sum and we're going to add it to the upper sum, and we're going to divide by 2. We take the average of those, right? And when we do that, when we do lower sum plus upper sum divided by 2, what we end up with, I computed it over here, so because I'm going to show you 2 ways to do this. We get 59.25 gallons. Okay, so that's a pretty good approximation of the number of gallons in the tank. So where before, I have a plane flying or something, the area under the curve represented total distance traveled. Now we have water flow, and so what we're going to end up with is that the total number of gallons when we get done computing this. So approximately 59.25 or 59.25 gallons have flowed into the tank, okay, at this point. Now, the question that may have bugged you was how accurate is the approximation? Well, just remember that error has to be less than or equal to the most extreme value, which in this case is our upper value, minus the average value that we use, okay, or found. So we would just subtract these two to see, what kind of error we might have. So it's the most extreme value minus the average that we found, and that turns out to be 4.5 gallons. And I'm going to show you that right now because this is the second way to do this. Rather than using the graph like I did, you could have just made a table of all the X and Y values. Maybe that's a little bit easier for you. You're not always going to have time to do something like this, but anyway, maybe it'll make more sense this way. So all I did was I took every value of time and I listed the corresponding output value in a little table that I made. Okay, make sure you understand and determine what your delta X is, your interval width. So let me just write that there. This is your, let me do it in red. This is delta X is equal interval width, the width of the subinterval. Right? So anyway, here I have my left-hand sum, and so I can just look at this table here and say, okay, my delta X is 1, and if I start at the leftmost, so I've got this first subinterval, I have 0, and then if I start at this subinterval, my leftmost endpoint is 1, and if I start at this subinterval, my leftmost endpoint is 3, and in this one it's 5, and in this one it's 6, and so as you can see, I'm just entering all those values in, okay, and computing that up with my calculator. I got 54.75 gallons. And then with the right-hand sum, again, if you think of this as your first subinterval, now I'm going to start with the, the width is 1, but the height is now 1. So I'm starting with 1, and the rightmost here is 3, plus the rightmost here is 5, plus the rightmost here is 6. So that's why that 0 is excluded there. Not that 0 would matter either way in this case, but 0 is not always an option, so you got to be careful. anyway, you add all those up, got 63.75 gallons. Okay, so this is my overestimate, this is my underestimate, and I know that the true number, the exact value, has to be somewhere in between that high and low. So what do? I take the average of the left and right hand sum, and so about 59.25 gallons. So this is quite a difference from here, and not so much, but could be significant depending on a situation in real life from here. So you know, these two are definitely not exact, but it's close. It's close enough, okay? And anytime you're dealing with this simple type of error, just always remember that error has to be less than or equal to the most extreme value you come up with, so the highest value, minus the average value that you found. Okay, so all I did was take this extreme value of 63.75 and subtract my average value from it. I got about 4.5 gallons. So you know, it's within 4.5. The area is going to be within 4.5 gallons. So I hope that helped, and if you have any more questions, be sure to let me know. Have a good night.